There are 5 main methods of factoring. First one is GCF, greatest common factor. You should always try to do this one. Most times you just look at a problem and see if they have something in common. Then there's grouping. That's 4 or more terms. PSD is when you have 3 terms of the form x squared plus bx plus c. Key number is 3 terms also, trinomial. And it's of the form ax squared plus bx plus c. Difference two squares is 2 terms with a minus tree in it, which is what we'll take a look at in this video. So let's take a look at x squared minus 49. Now first off, notice that there's no GCF, and we got 2 terms with the minus tree in it. So we're going to try to rewrite this as something squared minus something else squared. You take a look at each piece and you ask yourself what times itself gives you that. For example, the x times x gives us x squared, and 7 times 7 gives us 49. Now I'm going to label what's inside my first set of parentheses as f for first, and I'll label what's inside my last set of parentheses as l for last. And this is a formula. So we got f plus l times f minus l. Now everywhere we have an f, we'll plug in x, and everywhere we have an l, we'll plug in 7. So this becomes x plus 7 times x minus 7. And that's our answer. Let's take a look at another one. We got 9y squared minus 16. Now first off, I notice there's no GCF, and I got 2 terms of minus in it. That's what tells us difference two squares. So I'm going to try to write something squared minus something else squared. I'll start with my first piece, the 9. Well, 3 times 3 gives us 9. Now y squared. Y times y gives us y squared. And 16. 4 times 4 gives us 16. Again, I'm going to label what's inside my first set of parentheses as f for first. What's in my last set of parentheses is l for last. This is just a formula. F plus L times F minus L. Now everywhere we have an F, we'll plug in 3y. Everywhere we have an L, we'll plug in 4. So we got 3y plus 4 times 3y minus 4. And that's our answer. Let's look at another one here. We got 48 x squared minus 3 y squared. Now first off, I notice on this, they have something in common. They have a GCF. 48 and 3 are both divisible by 3, so I'll factor a 3 out. 48 divided by 3 is 16 x squared minus, take that 3 away, and it just leaves us y squared. Now look at what's inside the parentheses. I got 2 terms of minus tree in it. So I'm going to try to write it as something squared minus something else squared. Notice I put brackets there just to clearly separate the two. And we're going to try to write this as something squared. Well, start with 16. 4 times 4 gives us 16. X times x gives us x squared. And we're going to try to write this as something squared. Y times y gives us y squared. So I'll label this as f for first, label this as l for last. And our formula says f plus l times f minus l. 3 just keeps carrying down, doesn't change anything. Now wherever there's an f in my formula, I'll put in 4x. Wherever there's an l, I'll put in y. So we've got 4x plus y times 4x minus y. And that's our answer. Let's take a look at our next example. Okay, so we got x to the 10th minus y to the 8th. Now, to be honest, you don't run across a whole lot of this type in the college algebra books that I've seen. It might be 1 or 2, but not very many. Mainly it's like those first 3 are real popular. No GCF, and I notice it's 2 terms with a minus 3 in it. It doesn't have to be 2 terms even, but 2 somethings with a minus 3 in them. We try to write it as something squared minus something else squared. If you go on to trig, you'll find out you may have sine squared minus cosine squared. Not terms. Okay, now we ask ourselves what times itself gives us x to the 10th, and that would be x to the 5th. Now a very easy way you can determine that is you take whatever powers are here, which is the 10, divide by the 2. 10 divided by 2 gives you 5. Now over in this one, 8 divided by 2 gives you y to the fourth. Now we were able to write it as something squared minus something else squared. This is f. What's my first set of parentheses? This is L. What's my last? We got f plus L, f minus L. So wherever I have an f, I'll plug in x to the fifth. Wherever I have an L, I'll plug in y to the fourth. So I got x to the fifth plus y to the fourth, and x to the fifth minus y to the fourth. And that's our answer. Let's look at this one. We got 32 x squared z minus 2y squared z. First off, I notice I have a GCF in common. 32 and 2 both divisible by 2, so I'm bringing 2 out. And they both have a z, so I'll bring out a z. Well, 32 divided by 2 is 16. That z's gone, so it leaves me x squared. Minus, that 2's gone, that z's gone, so we got y squared. And we actually saw this right here, 16x squared minus y squared, so I won't show that part again. But this becomes 2z times 4x plus y, 4x minus y. What I want to demonstrate with this example is that sometimes you run across a problem and it's like, whoa, how in the world do I factor that? If you just factor out GCF, though, you'll find it's something you're very familiar with. Actually, in this case, something we've already done in the previous problem. So always look for the GCF. It doesn't always have one, but sometimes you cannot factor it unless you do bring up GCF. One last one. We got x to the fourth minus 16. There's no GCF, so I'm going to try to write it as something squared minus something else squared. Well, x squared times x squared gives us x to the fourth. And again, go backwards. Take this power here, the 4, divide by this. So 4 divided by 2 gives you 2. Now, 4 times 4 gives us 16. So I'll label this as f, what's in the first set of parentheses. I'll label this as L for what's in the last. And we've got a formula for that. So we're going to take what's inside our first set of parentheses, which is the x squared. We'll add what's in the last, so plus 4, and x squared minus 4. Now, this one we can go further with. The x squared plus 4 we can't do anything with, but x squared minus 4, two terms with a minus between it. So we're going to try to write that as something squared minus something else squared. Now, x times x gives you x squared, and 2 times 2 gives you 4. So I'll label this as f, what's in the first set of parentheses. I'll label this as L for what's in the last. And we get x squared plus 4 just carries along. In our formula, we'll have x plus 2 and x minus 2. I won't write the formula down again since we had it right here, but f plus L, f minus L. And that's our answer.